Hi class, let's take a look at example E. And in this case, careful because we're looking at an actual division of problems. So what I'm going to do is I'm going to first flip the fraction before we do any sort of a cancellation of values. So we're looking at the first fraction. It's actually x squared minus y squared over the values of x minus y. I'm not going to write the parentheses since it's technically not needed. It's in the denominator of the first fraction. And then don't forget that, well, technically your second fraction is going to flip. So we're looking at times an x minus y over x plus y times x plus y. But in this case, we technically have to the second power, so careful on that one. Now, what I'm going to do next is I'm going to factor all the actual fractions and then merge it as a single fraction. So notice that we technically have x squared minus y squared. This one is a difference of squares, which technically is going to factor as x plus y times x minus y. On the top, we have another x minus y, which happens to be from this portion here. So that would be this one. Now, in your denominator, you technically have x minus y from the first one times an x plus y. And then you have to be very careful on this particular one, x plus y. It's basically a squared value, which translates as x plus y times the values of x plus y. And let me highlight it in green so that you guys can follow technically where it came from. Now, once your fraction is completely factored out, you start canceling common factors. And for example, you can only cancel this x plus y with another x plus y at the bottom. And if you have a x minus y, like this one, you can cancel it with that one. For this particular problem, we run out of common factors. So the only terms that don't cancel on the top, it's going to be your x minus y. At the bottom, you have a total of 2 x plus y. So let me write them as x plus y times x plus y, or simply rewrite them as they originally were with the value to the second. So your final answer would be x minus y over x plus y, technically to the second power. Give me just a second. Now, as long as x plus y, it's not technically 0. So that would be our final answer for this one. Okay, let's take a look at the same type of problem, but in this case, we're simply looking at a multiplication. So for this one, what you could do is automatically from the first step, factor all common factors and see if any values are going to cancel. So I'm just going to rewrite the x squared minus y squared and factor it out. So you're going to have x plus y times the values of x minus y over x minus y, which is your first fraction. And then on the top, we're looking at just simply x plus y times x plus y and x plus y. These two x plus y represent the x plus y. And then don't forget about the value in the denominator of the first fraction, which is an x minus y. Now, at this point, you can start canceling common factors if you have any. So we can cancel the x minus y, that x minus y, And that's going to be it. Your answer on the top, you technically have 1, 2, 3, 4, 4x plus y's that don't cancel. And I'm just going to write them to the fourth power over, well, a single x minus y. And I'm just going to write them as x minus y is not technically a value equal to 0. So in this case, this is our final answer. Don't forget about the denominator. You're not allowed to divide by a value such as 0. That's why when we looked at the original formula, I basically wrote it in this form. Your denominators cannot equal to 0. And for these last a couple problems, well, you end up with variables in the bottom of the fraction.